All right, guys, let's get this study guide done. Ainsley ran 10 blocks in 5 minutes. If she ran at a constant speed, how long will it take her to run 2 1/4 blocks? Now, I need you to keep in mind that on this test, you're going to be asked two different things. You're going to be asked to either set up a proportion, or you're going to be asked about writing an equation or finding the constant of proportionality. So you've got, I'm going to turn this over to the back for a minute. So you've got your proportion that's going to find things like unit rate and that kind of thing. And then you've got your ratio, yk equals y over x, that we have to have, that then leads us to our equation of y equals kx, okay? And k right here and right here, k is going to be, your k is the unit rate, k is the constant of proportionality, okay? K is your rate of change. All of those things are K. It may ask you for this, or this, or this, okay? It may ask you for any of those. Those are all the same, and that's what that ways to say K circle map was that you did. So you may be asked, maybe ask a question asking you for a proportion, or you may be asked a question asking you about one of these things. This over here, this is where we did our tables. This is your graphs. Okay, this is tables and graphs. This is just going to be a basic proportion. So you're going to have to read the questions and determine, is it this or is it this? Okay, so let's go back over here and see what we got. Number 1. Ainsley ran 10 blocks in 5 minutes. If she ran a constant speed, how long did it take her to run 2 1/2 blocks? Well, this is asking me to set up a proportion. So I'm going to use my bridge map. And I've got blocks per minute. She ran 10 blocks in 5 minutes. So how long would it take her to run 2 1/4 blocks? I've got blocks and blocks, blocks and blocks, minutes and minutes. Now let's cross multiply. X times 10 is 10x. And now let's put this in our calculator. All right, so we go back and we do 2 1/4. And remember, putting the mixed number in, we've got to hit the second button, then the N over D button. That gives us our mixed number, 2 1/4 times 5 is 45 over 4. And you just leave it like that. Just leave that sitting there like that, because then I'm going to divide both sides by 10. And x is going to equal. So then I can just say divided by. Notice it says the answer divided by. So it's just taking that. I don't have to clear my calculator out and put that fraction back in. Divided by 10 is 9/8. Now, that's a mixed number. And I want to change that mixed number to an improper fraction. Now, you can't leave it like that, but you never know what the answer choices are going to ask you. So I'm going to hit the second, the X10N key, and that's going to give me that weird looking thing right there, and then hit enter. It changes that to 1 1/8 minutes. Okay. You may need to go back and just kind of rework this problem with me a couple of times so that you can practice putting that in the calculator, because that's going to be real important. But making sure you know how to get that in the calculator correctly. 1 lap around the path of the park is 1/3 a mile. It takes Andy 1/9 of an hour to walk 1 lap. What is Andy's unit rate around the park? So, one lap around the park is 1 mile. And it takes him, so 1 lap takes him 1/9 of an hour. And 1 lap is 1/3 of a mile. So he can walk 1/3 of a mile in 1/9 of an hour. So we want to know how long. This is 1/3 of a mile in 1/9 of an hour. How far can he walk? Oops. And we're wanting to know his unit rate around the park. So one lap. We want to know how long it takes him to walk 1 lap. How long does it take him to walk 1 lap? So 1/9 of an hour. I'm sorry. 1/3 x equals 1/9. Divide both sides by 1/3. And x equals 1/9 divided by 1/3. 1/3 of an hour. Now it told us that already. This is 1/3 of an hour to walk 1 lap, which has already told us that in the problem. This is really not a good question because I don't think the question's asking you what it really needs to ask you. So I want to show you there is, that's 1/3 of an hour to walk 1 lap. But let's look at what happens if we wanted to do this and see how long it takes, how far. No, we're not going to do that. I'm not going to do that because it says, what is his unit rate around the park? Well, it told you 1 lap is 1/3 of a mile. It takes 1/9 of an hour to walk 1 lap. That really is your unit rate right there. So we're going to just leave it at that and move on. The table below, determine the constant of proportionality. All right, your constant of proportionality is the ratio of, that's K. The constant of proportionality is K. And we know that K equals Y over X. Now, I don't want you, when it asks you for the constant of proportionality on the test, to tell me Y over X. I want a value. So this is always going to be X in a table. This is always going to be Y. So I'm going to come up here and get me a set of values right there. And I'm going to write them Y over X. So I'm going to write it 4 over 7. And that is my constant of proportionality. That's it. That's all I have to do. Take one of those values and write it Y over X. So that is K. 4 over 7 is K. Now I can come down here and write my equation. Y equals 4 over 7x. I'm now going to take that k and put it into my equation. The value of x in the table, looking at the pattern here, we know it's going up by 7 every time. So I can say that x is 21. On the map of Georgia, 22 centimeters represents 15 miles. Based on the map, what equation would calculate the number of miles between the two cities when they measure x centimeters apart? So first I'm going to look at this and I'm going to determine my values. Where's my x's, where's my y's? So the number of miles between two cities, y. So miles is y and x is my centimeters, okay? Now I'm going to come over here. X is centimeters, so 22 centimeters is my x. 15 miles is my y, okay? It's asking me for an equation. So if it's asking me for an equation, I know that I'm going to have k. I've got to have k. So let's do that first. So k is equal to y over x. Well, here they are, y and x. So k is equal to 15 over 22. Now I take that k and I put it into my equation, y equals kx, which is going to be y equals 15 over 22 x. So I had to have my ratio first, then I could write my equation. Determine the constant of proportionality for the table. The constant of proportionality is k. Here's my x and my y. I know that k equals y over x. So I'm just going to come right here and pick me up one of these. So y is negative 7. X is negative 2. Now, that looks incredibly easy, but where you're going to mess up right there is a negative divided by a negative is always a positive. So that is actually, I'll show you right here. Negative 7 divided by, or over negative 2 is a positive 7 over 2. Now if I change that to a decimal, it's a positive 3.5. So this becomes a positive 7 over 2, which is a positive 3.5, depending on what the answer's going to ask you for. Now I'm ready to write my equation. Y equals, and I can use either one of those, 7 over 2x, or y equals 3.5x. Determine the constant of proportionality for the graph. So to get the constant of proportionality down here, I've got to have k equals y over x. Well, remember, this is my x-axis. This is my y-axis. And I need it y over x. So I'm going to pull it off of this graph, starting with the y. I'm going to just use this point right here. I just need one point. So I'm going to come right here, and I'm going to go from here. And I'm going to come this way, draw my corner, and I have 5 over 1. 5 over 1. That's 5 over 1, which is 5. So the constant of proportionality here, k equals 5. once I have that constant and proportionality, then I can do my equation. Y equals kx, which is y equals 5x. Guys, I want to remind you, this is the answer, not this. This is the answer, not this. This is just this is the equation, but this is not the equation that represents this graph. The equation that represents this graph is y equals 5x. Okay? Which following is the least expensive price. All right. So to find the least expensive price, this is going to be unit rate. We've got to find the unit rate for each one of these. The better buy or the least expensive price is always going to be unit rate. And so I'm going to go over here and get me a sheet of paper so that I can do this on paper for you. So answer choice A. We're going to have to find the unit rate for each answer choice to figure out which one is the least expensive. Answer choice A. Cost per orange. So $1.02 for 3.5 oranges. How much for 1 orange? Cross multiply. 3 1/2 x equals $1.02. Divide both sides by 3.5. And x equals one divided by 3 1/2. All right, so that's going to be 29 cents. Okay, so this one is 29 cents. B. Cost per orange, $1.52 for 4 5/8 oranges. How much for 1? So we cross multiply. 4 5/8 oranges for x. Divide both sides by 4 5/8. X equals 152 divided by second n over d, 4 5/8. All right, so now look right here. I'm going to show you this, 0.328. I'm going to show you something. I only need this much to show it as money. But that 8 right there is going to turn that 2 into a 3. So this is actually 0.33. That's 33 cents. That 8's going to actually make that 33 cents. So this one is 33 cents. And that could make a difference. So we need to make sure we are rounding that correctly, okay? Answer choice C. Dollars per orange, 175. 5 5/8. Oh, 5 5/4. Sorry. How much for 1? 5 5/4 x equals $1.75. Divide both sides by 5 5/4. And x equals $1.75 divided by 5 second n over d and 5/4. And x equals 28 cents. And then D, cost per orange, $2.46 for 6 2/3. How much for one? 6 2/3 x equals $2.46. Divide both sides by 6 2/3. X equals and here's another one, 0.369. I only need that much for it to be money, but that 9 is going to make a difference with that 6, so it's actually 0.37. So this is 0.37. So our least expensive is C. This is number 11. And I'll make sure I upload this paper with the work on it when I upload the key. Okay. Heather works for a florist. She worked for 5.5 hours last week and made 20.5 bouquets. If she works at a constant rate, how long does it take her to make one bouquet? She works 5.5 hours and made 20.5 bouquets. How long does it take her to make one bouquet? So, hours per bouquet. So she works 5.5 hours and makes 20.5 bouquets. If she were, how long does it take her to make one bouquet? So, 20.5 x equals 5.5. Divide both sides by 20.5. And x equals, so we're going to go right here, 5 second and 1/2 divided by 20 and 1/2. It's 11 over 41. We're going to leave it just like that. So it takes her 11/41 of an hour. So x equals 11 over 41. And that's actually how we're just going to leave that. Write an equivalent ratio to show if the table has a proportional relationship. And guys, I don't like this question. We're going to just, but I don't mean to mark through that, but we're actually going to just mark out number 13. It doesn't, it's not a good question. Just mark it out. Just mark it out. Don't even do it. We can write the constant and proportionality for this table. The constant and proportionality for this table is K equals Y over X. This is always X in a table. This is always Y in a table. So if I need Y over X, I'm going to just come grab me one of these. And if you grab the first one, you usually have the unit rate or the constant of proportionality. Y is 6. X is 1. So the constant of proportionality here is 6. Therefore, our equation, y equals 6x. Santa's elves can build 12.5 Hot Wheel racetracks in 1/4 of an hour. How many Hot Wheels tracks can they build per hour? Well, they can build, we want Hot Wheels per hour, because we want that 1 hour down here. So 12.5 in 1/4 of an hour. How many in 1 hour? Per hour means 1 hour. Per hour means 1 hour. 1/4 x. I'm cross multiply starting with a variable. 12.5 times 1 is 12.5. Divide both sides by 1/4. Put that in our calculator. 12 and 1/2 divided by 1/4. So they can build 50 Hot Wheels in 1 hour. If there are 60 minutes in an hour, and it takes Lee 11/41 of an hour to make one bouquet, how many minutes does it take her? All right, 60 minutes in an hour. So there are 60 minutes in 1 hour. And we know that she can make this many in an hour. This is minutes and hours. And we know that she can make this many in 1 hour. This is also hours over here. Okay? This is hours. Hours, hours, minutes, minutes. We don't know how many minutes it's going to take her. So we cross multiply. X times 1 is x. 60 times 11 over 41. 60 times 11 over 41 gives us that crazy mixed number. I'm just going to change it to a fraction, a decimal. 16.1. 16.1. Well, look at what that gave me. It said 16.09, and I'm going to round that to 16.1. So it takes her 16.1 minutes. 16.1 minutes. Carson has a rectangle with the ratio of the rectangle's length to width being 2:1. If the length is 14, what is the width? So the ratio of length to width. So this is length right here. This is your length. This is your width. It told you the ratio was length to width. So 2:1 length to width. So this is length and width. Length is 2, width is 1. If the length is 14, what is the width? What is the width? So 2x equals 14. Divided by 2. X equals 7. Let's look at that. Let's break that down a little bit more. This is your length. This is your length. It told you the length. So we had to put all of our lengths in the same place. They had to be lined up. This was your width. This is your width. And then it asked for the width. So all of our widths had to be lined up. Adriana wants to build a new flower garden for her mother. She drew a scale drawing of the flower bed which she will use to create the actual flower bed. Her scale drawing is 4 centimeters by 7 centimeters. If her scale is 2:5, what is the actual size of the flower garden? Okay, So this is the best, these are the ones that, we drew our pictures of, okay? Her scale drawing. So this little rectangle right here is going to be my scale drawing. And it is 4 by 7, okay? So, okay, so what we've got to do here is, normally when we would draw our picture, we'd have one of these lengths and we could set up our ratio, right? Well, we don't have either one of those lengths, but what we do have is right here in the problem, it gives us the scale. So we're going to have to use that scale to help us, okay? But look at this. We're going to have to find the length using the scale, and then we're going to have to go back and find the width using the scale. So we're going to need 2 bridge maps. I'm going to come over here to my paper and do this one again on my paper. Pull that down so you can kind of see both. All right. So the first one I'm going to do is this yellow one. I don't think if I write with this yellow pen you can see it. Let's see. Yeah, you can, I think. We'll see. I'll go back over it if you can't. So I'm going to use my scale. So first I'm going to find the length. I don't think that's dark enough. I'll use this red. We'll just kind of draw over that red. That's red. Length. So I'm going to use my scale. 2 centimeters to 5 meters. And I know that my little one right here is 7 centimeters is how many meters? So we're trying to find the meters. So 2x equals 35. Divide both sides by 2. And x equals 35 divided by 2 is 17.5 meters. And that's your length. And then now we've got to do this again for the width. Now we've got to do it again right here for the width. This is our width. Two centimeters is 5 meters. So 4 centimeters would be how many meters? Cross multiply, we get 2x equals 20.